Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant update. I'm going to start with the important chapter from part 1, P block elements, with a very high weightage. Okay, before starting with the P block elements or any block elements, the first thing is to understand the Aufbau's principle. So Aufbau's principle was basically giving you the sequence of the energy levels in which the electron would enter. So if I talk about the energy levels, there are 7 energy levels corresponding to 7 periods in the periodic table, and the Aufbau sequence is: the first electron enters 1s, followed by 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, and 7s, 5f, 6d, and 7p. This is the Aufbau sequence. Okay? Now based on this sequence, if we observe S and P, they are lying to their ultimate shells, meaning 1s is present in first shell, 2s in second shell, 5s in fifth shell, 7s in seventh shell. If we talk about P, it starts with SP, meaning second energy level, and 2p is in the second shell, 5p in the fifth shell, 7p in the seventh shell. So we say S and P are present in their ultimate shell, which is represented by nth shell or the principal quantum number. If we talk about D, so first of all D will start with third energy level, meaning the first D orbital would be 3D. But if we observe, 3D is not in the third shell, it is in the fourth shell as per the sequence, 4D in the fifth one, 5D in the sixth one, and 6D in the seventh one. So if we observe D, then it is observed to be one time inner as compared to the ultimate shell. We call it to be penultimate shell, which is represented by n-1. Penultimate matlab n-1. If we see F, so first of all F starts with S, P, D, F. So pehla F subshell hoga 4F. But if we observe 4F is not in the fourth one, but it is in the sixth one. So it is 2 time inner as compared to the outer shell. And that's why this is called pre-penultimate shell or anti-penultimate shell. Okay? So sequentially, if we observe with respect to nucleus, let's say if the outermost shell is 6, then the sequence in which the electrons would enter is 6 के अंदर first 6s में जाएगा, उसके बाद it will enter in the pre-penultimate shell, that is 4f, then 5d, and then again in the 6th shell का 6p subshell. Clear? So as the electrons are entering with respect to the 6th energy level, we observe that electron has entered in the inner shells. So these inner electrons now cause an obstruction between the nucleus and the outer electron, which results into an effect called screening effect or shielding effect. Am I clear with this? When the electrons are entering in 6s, 4f, 5d, 6p, the electrons tend to enter in the inner shells, which are called inner electrons. These inner electrons cause an obstruction between the nucleus and the outer shell, which results into screening or shielding effect. So whatever exceptions we talk in the periodic table, they are mostly due to the shielding or the screening effect. ठीक है? So now P block elements या कोई भी block elements को define करने के लिए we have 3 words. Last electron entering into dash orbital of the dash shell. Correct? So for P block elements, the definition would be they are those elements in which the last electron enters the P orbital of ultimate shell. All elements in which the last electron enters the P orbital of the ultimate shell are P block elements. So what would be D block elements defined as? Those elements in which last electron enters D orbital of penultimate shell. F block elements के लिए last electron enters F orbital of pre-penultimate shell. Clear? Now in periodic table each block has certain number of groups, and the number of groups are decided by the capacity of the subshell. So if I talk about subshells, one more information, it is represented by azimuthal quantum number, and the azimuthal quantum number is represented by letter L, which takes the value starting from 0 to n minus 1 corresponding to a particular shell. So L ka values we can have as 0, 1, 2, 3, and they correspond to the subshells represented as sharp, principal, diffused and fundamental, which have the letters S, P, D, F. Clear? So azimuthal quantum number is represented by letter L. Now in the subshell we have orbitals, and the number of orbitals are given by the value of m, which is called magnetic quantum number, and this magnetic quantum number have the values ranging from minus L to plus L. So for L equal to 0 we can have only one value. That's why we say S orbital is spherically symmetrical, because it has no directional orientation. It is symmetrical along the x, y as well as z. P was having three orientations: Px, Py, Pz, and there are three orbitals corresponding to P subshell. Then D के लिए 5, which are named as dxy, dyz, dzx, dx square minus y square, and dz square. And then F के लिए 7. Now these number of orbitals of a subshell can be remembered as odd number sequence: 1, 3, 5, 7, 1, 3, 5, 7. And in the orbitals finally resides the electrons, and one orbital can have a maximum of 2 electrons only. So S will have a total capacity of 2 electrons, then 6, 10 and 14. Now corresponding to this electron ka capacity, we have the groups assigned to the particular block. So S block elements have 2 groups in the periodic table, and they are group numbers 1 and 2, which are named as alkali and alkaline earth metals, and they are placed to the extreme left of the periodic table as per the Aufbau principle also. Correct? P will have 6 groups, and they are from 13 to 18, and they are placed to the extreme right of the periodic table starting from period number 2. Okay? Deep subshell have 10 electrons capacity. Group numbers are from 3 to 12, the 10 groups, and they are between the S and P block elements. About F block elements, there should have been 14 groups, but the elements are so very similar that they were all condensed together in single group, and that was group number 3, placed after the S block elements. So यहाँ पे एक ही group relate होगा, and all the elements were placed at the bottom of the periodic table. ठीक है? So this was a general introduction about any block elements. ठीक है? Now in P block elements we have 6 groups, out of which 13 and 14th group was a part of 11th syllabus, and in 12th syllabus we are going to discuss about the remaining 4 groups, that is 15, 16, 17 and 18. And remember, group 15 if you understand, then 16, 17, 18 would be very easy. Vice versa, group 15 नहीं समझा तो भूल जाना ये चैप्टर को.